find the volume of this region in triple integrals, we need to be integrating over that region. The integrand needs to be a 1, and then dv represents our volume element, which we need to describe. And we're going to do that in cylindrical coordinates. We're told that the sphere here is x squared plus y squared plus z squared equals 100. We're going to change that to cylindrical coordinates. X squared plus y squared is the same as r squared. And so there's the equation for the green sphere. We were told in the problem that these are not necessarily drawn to scale, although that does look plausible. Likewise, the cylinder that we have here, we're told, is x squared plus y squared equals 1, which doesn't actually look plausible because it looks a lot like that cylinder has a radius a lot larger than 1. However, again, the instruction said this is not drawn to scale. Now, x squared plus y squared equals 1 just means r equals 1. The radius is 1. So there's the equation of those two things. So to set this up in cylindrical coordinates, we need to have our triple integral with either a dr, d theta, dz, or any other combination of that. Now you can see that what we are needing is we need the z's. Maybe I can use my green for that. We need the z's to go from the base, which is the xy plane, up to the surface. And that would be this. So we're going to begin our integration with a dz. And as I just mentioned, we're going to be going from the bottom, which is the xy plane, to the top, which is this sphere, r squared plus z squared equals 100. So what we need is we need this in terms of z. So if we solve for z, we get z squared equals 100 minus r squared. When we do the square root of that, remember that technically there's a plus and minus on this, but since we obviously are above the xy plane, we will use the positive one. And so now we need to either integrate with respect to the r, which I already have a representative one here, or the theta. Now it's not going to matter either one, because if we use the r's, then r is going to go from 0 to 1, a constant. If we use the thetas, they're going to go from 0 to 2 pi, since we have to go all the way around the circle. And the only thing that remains is the magical quantity that we always have to use if we're describing anything with r's and thetas, and that is the single r. So there's our integral. Now how you evaluate that is up to you. You can do this by hand, you can do this on your calculator. And the exact value on the TI-89 is quite complicated, but the decimal value comes out to be a 31.337255, and then there's some other stuff after it. But from there, we can round to however many decimal places we want. So that's how we do that in cylindrical coordinates.